Hello students, in this video we have last question of assignment 10.2 of wave optics. In first video we had these three questions explained. Now we have fourth one. Derive expression for intensity of resultant wave due to interference of two waves. Previously we saw that when two waves interfere, when two waves simultaneously superpose at a given point, the resultant intensity may be more or it may be less. If the resultant intensity is more, then we say constructive interference has taken place. But if the resultant intensity decreases, then it is said to be destructive interference. And we also saw that if the two waves are identical, then in case of constructive interference, the intensity is 4 times more than that due to individual wave. And in case of destructive interference, the resultant intensity is 0, provided that the two waves which are being superposed are identical. So in this video, we will derive one equation for resultant intensity, and then maybe in next assignment we will verify that is the intensity 4 times that of individual wave or if it is 0 for destructive interference. But in this video, we will just derive expression for intensity of resultant wave. So let us start. Consider a wave. Now first we'll talk about mechanical wave. It is easy to understand mechanical wave. So let us say this is a mechanical wave, and then there are several terms about mechanical wave which we must be clear with. Very first term is this distance which we denote with A. So when you write y is equal to A sine omega t plus phi, actually this is equation for oscillation of single particle. So whichever particle you have here is oscillating, and at any given time t, how much is the displacement of the particle we can determine by this. But if you are talking about wave equation, it is a sine omega t minus kx. So before we talk about light wave, we should be clear with all these terms. So if we are talking about mechanical wave, what is y? Y is the displacement, vertical displacement of any particle along this line. Suppose if you point out some particle, say particle here, what is the displacement of that particle at say 10 second? So we should be able to find out that displacement of particle is this much at 10 second or any given time. What is A? A is maximum distance, maximum possible distance by that particle. What about omega? So we know that omega is 2 pi f, or else it may be 2 pi by t. F is frequency, t is time period. What about k? So we know that k is 2 pi by lambda, it is wave vector. X is distance from the source, and one more thing we should not forget, that if it is negative sign, the wave is propagating in positive x direction. If you have omega t plus kx, you should understand that wave is moving in opposite direction, negative x direction. And of course, you can add one more term here. It won't change any physics, phi. It just indicates initial phase of the wave. So with this, let us now enter into wave of light. When you are talking about wave of light, suppose if I have two waves, let me consider that there are two sources of light, say S1 and S2, and the two are say separated by distance d. So I can always assume some point on the screen where waves due to this two are superposed. So now there are different possibilities. What are the possibilities? Possibilities are that the waves may be reaching point P in such a way that they help each other, means they give constructive interference, or else they may be negating, they may be giving destructive interference. So how do I know what will happen at point P? So to understand that, let us first define the equations of first and second wave. So the way we have mechanical wave, in case of light wave also, we have similar equation, except that instead of y you have E, instead of amplitude you have capital E, sine remains sine, omega remains omega, k remains k, phi remains phi. Okay, so in this case, what is y? Y is the resultant displacement, or sorry, displacement at time t. Similarly, E is electric field at time t. What is A? Maximum amplitude. What is E? Maximum electric field. Omega, K, phi remains same. So, in case of two waves, I can say that electric field due to first wave is E1, which is capital E1 sine omega 1t minus k1. Now let me label the paths with symbol r1 and r2. Okay, so instead of x, I will write r1 plus phi1, and second wave is giving electric field E2 at point P. It is having maximum value of electric field capital E2 sine omega 2t minus k2 r2 plus phi 2. Now we know that the resultant wave can be found out if we take resultant intensity. Intensity is proportional to square of amplitude. Okay, so I need to have amplitude of resultant wave. Now, how do I find out resultant amplitude from E1, E2 in this equation? Because we'll need to consider direction also. So for that, let us take help of phasor. Actually, if I want resultant electric field, I'll have to add this two, and adding two sinusoidal function is not easy job. So we can take help of phasor method. So I'll take phasor of this E1, phasor of E2. So here is my reference line, and with respect to the reference line, I first consider phasor of small e1, let it be, this is phasor. Say if you take horizontal component, it is E1 cos, vertical component is E1 sin. The angle I'll consider to be delta 1, and then on top of it I'll consider second phasor, say E2. Where is E2? E2 is taken at delta 2. So now if you extend this, you realize that this angle is delta 2 minus delta 1, and this is the resultant phasor E. And if I take vertical component, I'll get E cos, or sorry, E sine. Okay, so that is how we can find out resultant electric field, which we will not need because E is enough for us. So what is the equation of E? So we know from our previous chapter of vector in 11th standard that E square can be given as E1 square plus E2 square plus 2 E1 E2 cos of delta 2 minus delta 1. Angle between E1 and E2 only we want, so it is delta 1 minus delta 2. But we also know that intensity is square of amplitude, so I can always replace E square with I. Okay, so I is equal to I1 plus I2 plus what is even root of I1. Okay, so root of I1, root of I2, and cos of delta 2 minus delta 1. Now there is one problem. You cannot write this way. Why we cannot write this way? Because when you are talking about electric field, it is at some particular time. But when you are writing I, it is intensity, and then you will have to take average of delta 2 minus delta 1 over one cycle. And then I'll have to write this equation as I is equal to I1 plus I2 plus 2 I1 I2 and average of cos delta 2 minus delta 1. How will you find out average of cos delta 2 minus delta 1? So you will have to find out average over one cycle. So integration of cos delta 2 minus delta 1 dt, and as it is from 0 to t, let me mention it. The limit is from 0 to capital T, and hence you will divide it by t. Okay, and if I've forgotten mentioning what is delta, what is delta 2? Delta 2 is omega 2t minus k2 r2 plus phi 2, and delta 1 is omega 1t minus k1 r1 plus phi 1, sorry, phi 1. And hence, if I write cos average of cos delta 2 minus delta 1 again, it would look something like this: 1 by t integration from 0 to t, and integration of what? Integration of cos of omega 2 minus omega 1t minus k2r2 minus k1r1 plus phi 2 minus phi 1 dt. So once you find out cos delta, average of cos delta, you can substitute in this equation. Once you substitute it here, you will be able to find out intensity. Okay, and this is the expression of intensity of wave when intensity of resultant wave when two waves superpose. This cos delta term is called interference term because cos delta term decides what will be the intensity of resultant wave. So what happens if two waves are identical? What happens if the uh, wavelengths are same? If wavelengths are not same, that we will see in coming topics. For now, this is all. Thank you.